Sometimes we don't know where the road of life is going to lead us. For me, it led me to Launch Code, a place where purpose and passion collides, a place where you have an opportunity. Launch Code helped me launch a new career. It gave me that opportunity. So I want to give back. I want to be able to help a new generation of learners become developers by sharing all of my life lessons and all of my struggles and what it took for me to get to where I needed to be today. Launch Code helped me do that. Now let's go on this journey together. I'll see you there. Okay, so now we're in chapter 15, and this particular video is going to go through this whole entire chapter. It's not that long. The video may be a little longer, but I don't want to break the flow of this particular chapter because it's not that many sections to it. So let's get into it. If you're new to this particular channel and you would like to follow along with the curriculum, the link is in the description. It's free, don't cost you anything, don't have to download anything. So let's get into it. Chapter 15, Scope. Here's our learning objectives. Upon completing all the content in this chapter, you should be able to do the following. 1. Understand the context in which a variable may be declared: block, local, global, execution, context. Understand and properly declare variables in the best context for the intended use. Describe shadowing and how it affects variable visibility. Explain variable hoisting. Key terminology. Here's a list of key terms for this chapter, broken down by the page the term first appears on. You should make note of these terms and their definitions. Scope, local scope, global scope, execution, context. Using scope. Shadowing, variable hoisting. We've already kind of planted the seed on all of this, on the shadowing, the hoisting, the scope, local. I prepared you in prior chapters, getting you ready for this particular chapter. So let's get into it. The introduction. In the functions chapter, we saw that there were variables are declared and initialized in the code affects when they can be used. This idea is called scope, and it describes the ability of a program to access or modify a variable. Here's what we learned. Here's an example. We create a variable, declaring it and initializing at 0. Then the function, we call it cool function. Let B assigned to 2, assign 2 to B, and return A plus B. A is accessible inside and outside of cool function. B is only accessible inside of cool function. Quick question. What type of function is this? Is this a pure function? Is it an impure function? All right, leave the answer in the comments. Let's add some console.log statements to explore this code snippet. So we here let A, 0 assigned to A, console log A, it lets us know it's 0. We have the function, cool function, let B, and we're going to assign it 2 to B, and console.log inside of a template literal, A equals the variable which is inside of a $, curly braces, comma, B equal to the variable which is inside of a $, and curly braces. Whenever we use template literals, this is how we write that syntax. Then return A plus B. Then we got A, this is a compound operator, plus equals 1. So what does that mean? That means it's supposed to be adding 1 to A. Then we console log A again, cool function, console log B. So we are invoking cool function here. So let's look at our results. All right, the first console log is 0, which we expected. The second console log is 1, and so we got console log A. And so which console log came next, which is this right here, because we added 1 to A. Why didn't the function come before this console.log? Remember, it's not where you define the function, it's where you invoke the function. And here it is right here. And then we got a console log B. Reference error, B is not defined. Why is that? This is why we are introducing it and helping you to understand scope, because B, this console log, is outside of the scope where this B has been declared. Line 2 and line 11 prints the initial and incremented values of A. Line 13 calls cool function, and line 6 prints the value of A and B. This shows that both variables are accessible within the function. Line 14 throws a reference error showing that B is not accessible outside of the cool function. Block local scope. Local scope refers to variables declared and initialized inside a function or block. A locally scoped variable can only be referenced inside of the block or function where it is defined. In this example above, B has a local scope limited to cool function. As we can see, B is only local to that scope to that function. Referencing or attempting to update a B outside of the function leads to a scoping error. And so, like I was saying, we were talking about local scope. So whatever is inside of your function, whatever is inside of those block code of your conditional, whatever is in the block code of your loops, is local to that particular block. So anything outside of it won't have reference for it. So inside of your function, you may have a condition that has a variable that's only local to that particular conditional, although it's inside of the function. The whole function has access to it. But if you try to do a console.log or something outside of that particular conditional, it's going to give you a reference error because it hasn't been declared if it's only inside of that particular block of code. So understanding the difference between the block and local scope is what this piece is talking about. And here's the example. It says the following code block has an error related to scope. Try and fix it. So here we give you the example. Remember, whatever is inside of this block is accessible. You already seen this, we talked about it. So look at it, think like the compiler, what's wrong with this, and then fix it. Global scope. Global scope refers to variables declared and initialized outside of a function and in the main body of the file. These variables are accessible to any function within a file. In the first example above, A has global scope. A, which is the variable, has global scope. Global scope is the default in JavaScript. If you assign a value to a variable without first declaring it with let or const, then the variable automatically becomes global. Let us look at this. So here we have the function cool function. It's a code here can use new variables. New variable is assigned to 5, returns new variable. So what are we saying here? We didn't initialize this with, or we didn't declare it with let or const or even var. It has no keyword on it. So what we're saying is this right here is going to be accessed globally, because remember, in JavaScript, what we just read, global scope, it is right here where it says in JavaScript, it's default. Global scope is default in JavaScript. So that's why we don't use var very sparingly, that we use the keyword var. And we'll explain a little bit more when we talk about hoisting. Now in the loop, for I is assigned to 0, I is less than string.length, I plus plus. Leaving off the left from I means that I is treated as a global variable. Any other portion of the program can access or modify I, which could disrupt how well the loop operates. Now, some of you have tried this, or because you followed along with the curriculum and you just copied what you saw. And you might have left the keyword let off. But if you remember, I said this can have unintended intentions because, or consequences, that it's going to be hard to debug because we left off that keyword. Now I has become global, and anything outside of this for loop can access it. Execution context. Execution context refers to the conditions under which a variable is executed. Let's pay attention to this. Its scope, scoping affects the variable's behavior at runtime. Remember this. Scoping affects the variable's behavior at runtime. When the code is run in the browser, everything is first run at a global context. I'm going to explain in a minute. As the compiler processes the code and finds a function, it shifts into the function context before returning to the global execution context. This is why we say that it's not where you define a function, it's where you invoke the function. It's when it's going to actually go through its line by line or its runtime. So this is why I was saying that JavaScript run line by line. So what happens first? The compiler comes down to the first line, let A assigned to 0. It runs that, it checks that first. Everything is good there. Then it sees this function definitions and define, but it doesn't do anything yet. It just keeps going until it's invoked. Now when we hit the console log cool function and then cooler function, then it runs it. So by just looking at how this looks, it looks like it's going line by line. It doesn't do anything until it's invoked. This is what we're talking about, execution of context. And then once it's been executed, then the compiler goes into the actual function line by line. And then once it hits this returns, it go ahead and stops the function. And then when the next function is invoked, then it will hop into that function and go line by line. And when it hits the return, then it stops. Remember, whenever you hit the return, it terminates the execution. And remember, your final return should be close to the closing curly bracket. If you put this return before this C plus equal this compound operator, it's not going to run this compound operator. Remember that rule. Now, let's consider the execution context for each step. First, the global execution context is entered as the compiler executes the code. Here's the example. Global execution, A is accessible, B and C are not, because they are inside of what? These functions. They're local to those functions. They're not global. Once a cool function is hit, the compiler creates and executes cool function under the cool function execution context. So here we go. Cool function, A and B are accessible, C is not. Global execution context, A is accessible, B and C are not. See, A is accessible in cool function because it's global. Upon completion of the compiler, returns to the global execution context. And then global execution context is A is accessible, B and C are not. The compiler stays at the global execution context until the creation and execution of cooler function, meaning not when this gets invoked, Then the compiler now goes locally inside of that function, where it says A and C are accessible with B or not, because in this cooler function we have C declared and B is not declared. So only A is accessible in both functions because A is global. C is only local to cooler function. And remember, what type of functions are these? Cooler function and cool function, remember, are they pure functions? Are they impure functions? Keep practicing as you keep going forward, just to remember concepts as we keep moving along. Now, inside of cooler function is a call to cool function. The compiler will go up and execute context to cool function before returning down to cooler function execution context. Upon completion of that function, the compiler returns to the global execution context. So once it hits those returns, then it comes out of those functions and then it goes back to the global execution. Now remember, let's go back up here for a second. Think about this for a second. We are calling the cool function inside, or invoking it inside of this cooler function. And so when it says return C, it's giving me access to C and it's running this cooler function. So it goes back up here and it actually runs this code inside of the cooler function to be able to get the results that we're looking for. Now, inside a cooler function, we have the three, right? Cool function, A and B are accessible, C is not. Cooler function, A and C are accessible, B is not. Global execution context, A is accessible, B and C are not. Because remember, they are local to those functions. Cooler function, A and C are accessible, B is not. Global execution context, A is accessible, B and C are not. And then global execution context, A is accessible, B and C are not. So if you get the pattern here, you see that when we're working with global execution, it has to be outside of whatever code block. It has to be at the top level. It has to be at the top of the tree, with inside of your component or inside of your files. So make sure we wanted to kind of touch on that. It's important to understand scoping and remember the term execution context, global execution context, and local execution context. So go ahead and check your understanding. Let's go on to the next one, scoping. We're going to keep this video going. Using scope. Scope allows programmers to control the flow of information through the variables in their program. Some variables you want to set a constant, like pi. You want this to be a constant, which can be accessed globally. Others you want to keep secure to minimize the danger of accidental updates. For example, a variable holding someone's username should be kept secure. So what are we talking about here? So for instance, if I do want to make pi of a variable that's holding pi globally, I will want to keep that as a constant. And we know what constants are. Const keyword lets us know that it is immutable. We can't change it. So here, shadowing, and we've kind of touched on this early on. We planted the seed on shadowing, gave you some examples, but now we're about to break down what shadowing is. Variable shadowing is where two variables in different scopes have the same name. Remember that. This is when you see two variables with the same name, but they're in different scopes. That's where we get the shadowing. The variables can then be accessed under different contexts. However, shadowing can affect the variable's accessibility. It also causes confusion for anyone reviewing the code. So here we go. We have our example. We have the require which is getting importing the readline sync module, and we're storing it inside of this input variable, which now is an object. We can get access to it through a dot or a bracket if we needed to, but we will use a dot access modifier to get access to this particular module that's been held in this variable. Now we have two functions here. Now remember, now we're going to read globally. These two functions right here won't do anything until they're invoked. So if they never get invoked, only lines are going to be read as line 1 and line 14. Now once they're invoked, then that's when they're going to run. So here inside of the function, in the scope of the function, we have what? We have variable, we got a parameter name and function hello. But look at double name. We have another parameter called name, because remember in parameters, they're just variables, right? And they're local to those, the scope to those particular functions. And so it's the argument that makes sense. But again, they don't mean anything outside technically, because they're only local to this particular function. But this is where shadowing comes in. This is where an issue can come in. So here we have the console.log. We say hello and name. We pass whatever the name. Once we invoke it, we're going to pass it a name. And then name is assigned to Ruth. And then return double name. Okay, wait a minute. So we're invoking now inside of this particular function, the double name function, which also has name. Console.log name plus name returns name plus name. Now here on line 14, we create a variable called name, and we are inputting the question where we're adding the input, and we're asking the question, please enter your name. Now when we invoke hello and pass name, and double name pass name, and console log pass name, what's going to happen? So what is the value of name in line 4, 10, 16, 17, and 18? Now, if you go ahead and play around with this to kind of figure out, okay, let's see what actually happens so you can visualize it. Then come back and let's finish this section up by understanding what we're talking about, to help you understand what has happened. Now, if you just came back to the video after pausing it and looking at this code and running it to see what the results will be, we read, yikes. This is why shadowing is not a best practice in coding. Whenever possible, use different global and local variable names. So what are we saying? Don't let your global variable name be the same as your local variable name. If it's going to be globally named here, then call this something else. Give these parameters. You don't have to call this parameter name. You could have called name 1, or you could have just put a letter A. It's a parameter for the actual argument. But here we are assigning name. Here we made it a variable that's storing information locally. And we did the same thing with double name over here as well. So you can see where the confusion comes in at. So as you try it, if you are curious about the name values in the example, feel free to run the code within the JavaScript example directory. Now, variable hoisting. Variable hoisting is a behavior in JavaScript where variable declarations are raised to the top of the current scope. This results in a program being able to use a variable before it has been declared. Hoisting occurs when the var keyword is used in the declaration, but it does not occur when let and const are used in the declaration. This is why we explain to you, you limit when you're using var. You use it in rare situations. If you run across the var keyword, you're either working in legacy code, meaning very old code, because of this problem right here, hoisting. Although we don't use the var keyword in this book, you will see it in a lot of other JavaScript resources. Variable hoisting is an important concept to keep in mind as you work with JavaScript. Check your understanding. We made it to the end of this chapter. Again, this video is a little longer because these sections wasn't that long, so I just wanted to kind of keep them together so you can get through this chapter. Now, understand we are introducing and helping you to reinforce what scope is, global and local, and hoisting, and understanding the execution context, when to execute different things. Play around with this code, get familiar with it, understand what happens if you give variables the same name, understanding how the shadowing works, because that can be a problem. So understand the rules and the principles so that you can use best practices in your programming, and you will become a very skilled developer by continuing to do. The more you do, the more you improve. That's the end of this chapter. See you in the next.